Welcome all of you to this video of Maths Made Easy. Now, as I said, this topic, specific resistance, is a little, it's a little neglected topic. Okay, but lots of questions come on this concept. So we will first understand. What specific resistance is, and then we will start doing numericals on this topic. Okay, so let's start quickly. Here, if we know that resistance is dependent on many things. Firstly, more the L, more is the resistance. Okay, more the length of the wire, more is the resistance of the wire. More is the area of cross section, less is the resistance. Means thicker the wire, lesser the resistance. Okay, now more is the temperature, more is the resistance. All these are directly proportional. This is inversely, these two are directly proportional to the resistance. So how we write it now? We use a constant. This is the constant which is called specific resistance, and then we use L here, A here. T does not come in this formula. So this is R, resistance, is equal to specific resistance into length into area of cross section. Okay, so this is our formula. Now here in this formula, this R has to be in ohms. Okay, ohms, I'll write it here. This has to be in meters, all SI, and this has to be in meters square. Okay, now how will we find? Now this specific resistance is a constant. Okay, this is a constant. But then why is this a constant? This is a constant, but then why it is this a constant? Now there was, when we learned about specific resistance, when we learned about resistance of a wire, there was a fourth condition which we are missing. That fourth condition was nature of the conductor. Okay, the fourth condition was nature of the conductor, that is resistance also depends on the nature of the conductor. Now if I talk about this, this specific resistance, it is this value, the value of this rho over here, we call it rho, specific resistance, is the value or is the variable here that is representing the nature of the conductor. What I mean by nature of the conductor is, if I have two conductors of the same length, the same thickness, everything same. Okay, the same length and the same thickness, everything is same. But then if one is made out of copper and another is made out of silver, then copper will have a higher resistance and silver will have a lower resistance. Okay, in spite of the same length, same thickness, and let's say even same temperature. Okay, now what is that factor which is differentiating between, because both don't have the same resistance in spite of being same length, same temperature, same thickness, they still will not have the same, resistance because the material is different. Okay, now what represents the material? It is the specific resistance which represents the material. So if you see your textbook, you will see a particular table given for specific resistance of different material. Okay, so you'll find their specific resistance of different materials. Just by looking at the specific resistance of the material over there in the chart, you can understand which particular element has more, which you can compare between the resistances. Okay, and the L, that is the length or the area of cross section, is not considered there. Only the material gets considered there. Okay, that is the meaning of specific resistance. The only one thing, now this specific resistance, the only one thing specific resistance depends on is the temperature. So if you see the table that is given in your textbook, it will be written specific resistance at 20 degrees centigrade. Okay, so that if the temperature increases, even for copper, the value of specific resistance will increase, the value of Ag will also increase. So at one particular temperature, you have to compare the specific resistances of all the materials. So if I am doing a sum with different lengths of wires, different thickness of wires, everything is different, but then both are made out of copper, then one value which is going to be same is the value of rho. Okay, as long as the material is same, the rho is same. Okay, so here how to find the unit of rho. Now even this has a unit, so you don't have to remember everything. All you do, keep the rho in one side, r into a by l. Okay, so r is what? R is in ohms. Okay, a is what? A is area of cross section and this is length. Now see, we are calculating the units. Okay, so specific resistance unit is ohm meter. Okay, so the unit of specific resistance is a ohm meter. Okay, so now let us start with the sums. As we do the sums, you will see that you are being able to understand this much better. Okay, so let us start. There are two wires of same material. Okay, there are two wires of the same material. This has to be noted. And same length. The length is also same. Only the thickness is differing. In one it is 1 mm and in one it is 2 mm. Compare the resistances. Compare their resistances. Firstly, you have to find, compare means what? What does compare mean? Compare means you have to get a ratio. Okay, compare can be done in two ways. One can be greater than, lesser than. One can be just it is a ratio. Okay, and their specific resistance. So we have to find a ratio between their resistances and find a ratio between their specific resistances. Okay, so two wires of the same material. So the specific resistance of the first wire, let it be R, and the second, let it be R dash. Okay, so now we will write the formula rho L by A. Okay, this is rho L by A dash. Now why I did A and A dash is because the thickness is differing. Length is same, so I use the same variable. Now here length is same, material is same, radii is 1 mm and 2 mm. So rho, then L, 1 is the, here area of cross section is pi r square, but then r square is I am taking in mm. Okay, though everything else is in SI. I'll tell you why. Okay, rho L and this is 2 square and pi 2 square. Okay, so this is for the two wires. Clearly for the two wires I have taken. Now here I am not changing the mm to meters because it is not required, because as long as you find a ratio mm to meters, I would have divided by 1000. Here also I would have divided by 1000, but m square, millimeter square, so 10 to the power 6 I had to divide by both of this. But what happens, because it is a ratio, at the end of the sum the entire thing gets cancelled. Okay, so entire the 10 to the power 6 will get cancelled and we will come back to this type of a condition only. Okay, so the entire 10 to the power 6 gets cancelled from both, so it is not required to write it as long as it is, to convert it as long as it is a ratio. If it is not a ratio, supposing it is a sum, okay, it is a addition, or supposing it is a not an addition, it is a subtraction, something like that, then you have to change. Okay, you have to convert mm to meters. So let me first compare the resistances R by R dash, that is rho L pi 1 square. Okay, divided by, so everything that is in the denominator goes to the numerator here. So here divided by pi 2 square rho and L. Cut the rho, cut the L, pi gone, so it is 4 by 1. So the ratio becomes 4:1. The second part of the sum we don't have to do only. Okay, now why we don't have to do the second part of the question? We don't have to do it because compare their specific resistances. Material is same material, they have told, you can check the question. If it is the same material, why do we need, the ratio between them is equal. So the ratio between, for specific resistance, this part is, that is rho and rho. It's not when rho and rho dash. It has to be 1:1 because it's the equal value. Okay, so this was the first question. Let's see few more questions like this. This is our second question. A given wire of resistance 1 ohm, they told the resistance, is stretched to double its length. Okay, it has been stretched to double its length. What will be its new resistance? Now, why they made this question at all? They made this question because we know that more the length, more is the resistance. But then remember one thing here, it is the same wire that they have, made long. They have elongated the same wire. So the wire, considering the material in the wire is the same, the wire must have become thinner. Thinner means, what does thin mean? Thinner means it has, the radius has increased. The radius has decreased. Okay, for the wire. So now what to do? A given wire of resistance 1 ohm, okay, is stretched to double it. So here R, okay, resistance R and R dash. What will be its new resistance? This is the new resistance, this is the old rho and rho, because both are same material. L here is L, and then area of cross section is, let it be A. It is stretched to double its length. So L becomes 2L here. What will happen to the area of cross section? Now this is one thing you all should know. If the length is doubled, then the area of cross section reduces to half. Okay, not the radius. Don't misunderstand me. It is not the radius that becomes half. It is the area of cross section which becomes half. Okay, so here it is A by 2. By 2 means it will go up, isn't it? By 2 here goes up. Now, what will be its new resistance? Now, I will do some changes in this. Rho L, okay, rho L A. Just these three things. Whatever is here, same thing I have taken out of this and written it here into 4. Okay, rho L by A is equal to capital R. Capital R means the previous resistance, and the R value over here was a 1, right? Rho L by A was a 1. So into 4, which is 1 into 4, that is equal to 4 ohms. Okay, or you can write it like this, 4 ohms. Okay, so that is, the new wire has a resistance 4 ohms when the old wire had a resistance of only 1 ohm. So you see, because the length has been doubled, the resistance of the wire has become 4 times the original resistance. Okay. Here is the next question. A wire of resistance 3 ohms and length 10 centimeter is stretched to a length of 30. So let me first start old. Okay, this is the old one, rho L A, and R dash rho and length 30. Okay, here if this is, here it is rho, and then initial length was 10 and area of cross section we don't know, we'll just keep it as A. Okay, here it is becoming 30. It became 3 times and stretched, and area of cross section, if the length has been made same wire piece and the length you make it to a 30, then the area of cross section will be divided by 3. So here you get the 3. Okay, so now the value of this R is 3. Okay, so rho by A into 10 is a 3 ohms. Now we'll keep that ready. Rho A into 10 into 9, right? I'm taking the 10 here and of this 30 and then giving the 3 to this 3, 9. Okay, how much is it? Rho A by 10. Rho A by 10 is how much? It is a 3. 3 into 9, which is a 27 ohms. Okay, so that is the new resistance of the wire is at 27 ohms. Now in these sums, what you have to understand is, see that this separating out this R value, that you have to learn. Okay, and then substituting with this value of R. Sometimes we also have to substitute the direct R only, because when it is not a value of R but straight R, when we have to find a ratio sometimes. Okay, so this A, even if you don't know the value, it finally disappears in the calculation and it finally gets reduced, and then this the centimeter here and the centimeter here we are not changing once again, because in this it will, if we are substituting here, then it would have finally got cancelled out. Now this question, a wire of resistance 9 ohms they are given having a length of 30 centimeter. Okay, so it has a length of 30 centimeter is tripled on itself. Now what's the meaning of tripling on itself is, if this is the long wire, you are folding it and folding it. This is tripling on itself. Okay, so having length 30 centimeter is tripled on itself. What is the new resistance? So now if R is the initial one, initial resistance, rho, it is the same wire, L is 30 and then tripled on itself, and area of cross section is A, rho L by A. Now R dash is rho will be same, material is same, tripled on itself, length has become 10, but area of cross section in this time will become 3A, because if you join up these ends it becomes a thicker wire, so it is 3A now. Now this is something you'll have to learn. What is the new resistance? You have to find the value of this rho, and then here rho by A. Okay, and here this value is how much? This value is 9, rho by A by 30. So rho by A is a 30. I'll just substitute it here. Okay, and then I have a 10 by 3, right? Rho by A is a 9 by 30. Correct? Rho by A is a 9 by 30 into 10 by 3. So here this cancels, and it is a 1 ohm. Okay. So the new wire, after it has been tripled on itself, becomes the resistance of the new wire becomes 1 ohm. Why? Because it reduces from 9 to 1, the thickness becomes more, area of cross section becomes more. Okay, if the area of cross section becomes more, it has become a thicker wire by folding, so it is now having lower resistance. Okay, and also it has become a shorter length. Shorter the length, lower the resistance. For both reasons, the resistance has come down to 1. What length of copper wire of specific resistance 1.7 into 10 to the power minus 8 ohm meter and radius 1 mm. So radius is given in the sum and specific resistance value is given, so that its resistance is 2 ohms. So we just have to put everything in place. R, rho, L, A. Okay, 1.7 into 10 to the power minus 8. Then length we don't know, area of cross section, radius we know is 1 mm. Now this is rho into m, rho m. So this is an SI, we have to convert 1 mm to SI now, because it is not going to, we are not going to find a second radius or anything, a second resistance or anything. So 1 mm is pi, okay, and r square. Now r is how much? 1 mm is 10 to the power minus 3 meters. Okay, so 10 to the power minus 6 for mm square, and here how much is 2. Okay, so this is 1.7 into 10 to the power minus 8 by 22, and the 7 comes here, and then L, and then 10 to the power minus 6 is 2. Okay, so if I calculate this, then I will get, so L is how much? 2 into 22 by 1.7 into 7. Okay, I am just cross multiplying and leaving the L on one side. Now this is 10 to the power minus 2. That is going to come down here as 10 to the power minus 2. Okay, now if I want to take it up above, it is going to be 2 into 22 by 7 into 1.7 into 100. Okay, into 100, and that is, on calculating this, we are going to get a 369.4 meters. Okay, that is our answer, 369.4 meters. So these were few of specific resistance questions which I thought is very important for your exams, especially the tripled one, the wire tripled on itself, and the wire which is you are elongating to double its length or triple its length. Those are the highlights of this video. You must remember to do those sums. Okay, especially I made that video for those two sums itself. Okay, so this is what specific resistance is. In your textbook you'll find some more reasons for what are the factors on which specific resistance depends and things like that. So there will be slight theory after this which you can learn. Okay, so that is it for today. If you have liked the video, do not forget to like, share and subscribe. Also, I'm still waiting for your comments. Do leave a comment behind. Okay, thanks for watching the video. Bye then.